Okay, hi guys. So today we're going to look at finding the equation of a quadratic from a graph. So the first thing we need to look through are what are some of the different ways that we can represent a quadratic. Now, we talked about yesterday, and if you didn't watch yesterday's video, I do recommend that you watch it because I think it's really helpful. So we talked about the fact that you can represent a quadratic in what we call turning point form, which is when you've what am I doing there? Which is where you've got the equation in the form whereby the values here, b and c, b comma c, they would give you the coordinates of the turning point of your function. All right. The second way we can write a quadratic is kind of as we know it, which is where you've got your ax squared plus bx plus c. So that's an expanded form. And the last way is if we converted that expanded form to factorized form, we could also write our quadratic like this, whereby b and c are our x-intercepts, because if we made this then equal to 0, we would have 0 equals x minus b, so x would be equal to b, or 0 equals x minus c, so x would be equal to c. So that's our intercept form. And the way you decide on how you're going to get the equation of a quadratic from a graph is depending on what information you have in your graph that you can see. So if I look at this one here, I can see that I have an intercept at A at -1, an x-intercept. I also have a y-intercept, another x-intercept b at 3. So I'm going to use my intercept form of my equation to find out my final equation. So from here, I've got my y equals a, x minus b, x minus c. Now I know that these values correspond to the intercepts in the graph, remembering that when you put them into the brackets, they're the opposite sign. So that's going to be -3, and that one's going to be +1. So this is then going to be y equals a, x plus 1, x minus 3. All right. Now from here, you'll notice we've got this a out the front. And again, if you watched yesterday, that's because you can have values out the front of your x squared. So we can have quadratics that look like this. We can also have quadratics that look like this. And if you don't take into account that there could be a value out the front of that x squared, then you're not properly solving for your equation. So how do we find if there's a value out the front of the x squared? Well, what we do is we pick one other point on the graph that we know. I'm going to use the y-intercept here, which is 0 for x, -6 for y. And I'm going to sub in those values in for x and y in my equation, and I'm going to solve for a. So in here, if I know y is -6 and x is 0, I'm just going to write that there, 0, -6. Then I'm going to sub in 0 for x, so we have 0 plus 1, 0 minus 3. Right, from here we have -6 equals a, 1, -3. So therefore -6 equals -3a. Therefore, if we divide that by -3, -3 goes into -6 2 times, so a is equal to 2. So therefore, now I can write out my final equation. So y equals 2, x plus 1, x minus 3. Now, the last thing that we should always do when we're writing a quadratic equation is we want it written in our expanded form. So we're now going to go through and expand this to get our final equation. So that's 2. Now we're going to use FOIL here. X squared minus 3x plus x minus 3. So here we've then got 2x squared minus 3x minus x is -2x, so minus 2x minus 3. And then we can multiply all of that by 2 out the front, so we're going to have 2x squared minus 4x minus 6. And that's our final equation. Alrighty, looking at the second one here. Now, in this case, we don't have the intercepts. We could probably roughly assume that that's around about 3 and that one's around about 5, but we don't know that for sure. So we're going to use, instead of using our intercept form, we're going to use our turning point form. So our turning point form is this one. And the difference between this and the intercept form is that we sub in the coordinates of the turning point instead of the coordinates of the intercept. So we know that we've got coordinates of 4, -5. Now again, that whatever's in the brackets, that's the one that needs to change the sign. So that C, that's going to stay as -5 because that's the up and down movement. Okay, you've moved 5 down. We've also moved 4 across. And that's going to be -4 because we're moving it to the right. So we're going +4, so that means in the brackets it has to be -4. Again, if you're not sure on what I'm talking about, watch yesterday. It'll really help. All right, so y equals a x minus 4 squared minus 5. Again, we have that possible value out the front, that possible a value. So now in this case, we're going to look at a different point. And that point, usually, so I forgot to write it in here, I should have done. Usually you'll either be able to exactly see your y-intercept, or your sneaky question will give you a second point on the graph. So it might tell you that this point here is 5, -2. And that'll exactly tell you that works, and that's going to give you the right point. Because otherwise you might make the mistake of, say, for example, assuming that this point here is 6, 6, and that actually isn't. It doesn't exactly go through 6, 6. It almost goes through 6, 6, but it doesn't. So normally you'll be given that extra point just so you don't make any reading errors. But all right, we'll go from here. So we're going to use 5, -2. Now, so y is -2, okay, and x is 5. So we're going to sub that in. All right, from here, 5 minus 4 is 1, 1 squared is 1. So we're going to end up with -2 equals a, 1a, minus 5. Now the next thing is we're going to add that 5 to the other side. So we end up with a equals 3. So therefore, our equation is now 3x minus 4 squared minus 5. And this should make sense, again, in the context of yesterday, looking at those transformations, because it's quite skinny. So we expect to have a number that we're multiplying out the front. So remember, that causes that stretch, okay, that makes it kind of longer and thinner than it was before. And 3 is quite a big stretch. So that's where that comes from. Now, again, the last thing we want to do is write our equation back in expanded form, because that's how we like to have quadratics. So we're going to say, so this is x minus 4 minus 5. Okay, so we're going to expand these brackets, and we get x squared minus 4x plus 16 minus 5. So that gives us y, x squared minus 8x plus 16 minus 5. Now we can multiply all of this by 3. We get 3x squared minus 24x plus 3 times 16, 32, 16, 48, minus 5, so we have 3x squared minus 24x, 48 minus 5 is 43, so plus 43 on the end, and there is our equation. Okay, last thing we should probably just talk about quickly is just remembering where you've got a negative function. So I'm just going to make one up here. Okay, so if, for example, we had this one, we've got a y value of 4, x value 14, so 14, 4. Now, if we were putting this one together, ignoring the a value for the moment, because we're just going to do it really quickly, my equation for this function would be y equals negative x minus 14 all squared in turning point form, of course. Okay, so you've got the x value squared. Okay, then plus 4, that gives me the y coordinate of the turning point. And then it's negative because that's upside down. Okay, now usually, again, you would have to find that second point, put in that a value and solve. But that's just how you do it with a negative one. All right, I think that's it for today. Pretty nice and quick. Hopefully you find that reasonably easy. Go on and do the rest of the work from there, and I'll talk to you on Friday. Okay, bye.